the silence cost to our water and environment. My name is Siti Khadijah, and I will be the moderator for today's discussion. So, before we begin, I would first like to welcome and thank our panelists for joining us today. We have Sorayya Fachri, Savira Andriani Fachri as panelist one, and Nurdini Arina, Aisyah as panelist two, Nurdini Arina as panelist three, and Hanchang as panelist four. So, today's discussion focuses on SDG 13, climate action, where we'll be talking about climate change and promoting environmental sustainability. Just as an introduction, artificial intelligence or AI has now become an essential part of modern society. I'm pretty sure the current generations these days can't deny that we use AI nearly every day in their lives. While AI benefits in many areas such as education and healthcare, there are still environmental impacts that are often overlooked. According to Kufoglu in 2022, technological development can support sustainability efforts, but it is also important to manage it responsibly to avoid environmental degradation and resource overuse. Today, we will be discussing alongside our panelists about several environmental concerns related to the growth of AI, which includes transparency, water consumption, heat generation, and energy use. So first of all, I would like to invite our first panelist, Savira. Many people view AI as digital technology. Why should we be discussing its water footprint though? All right, please go ahead.
Okay. Good morning, everyone. My name is Savira Andriani. So I'm the first panelist of this discussion today. Although AI is often seen as a digital technology, it relies on physical infrastructure such as data centers. These facilities require large amounts of water for cooling and electricity generation. So according to research by Shao Lauren from University of California, Riverside, AI system can have a significant water footprint due to researchers needed to operate and cool data centers. As, A, as AI usage to continues to grow, its demand for um, water also increases. So that's why um, we really need to discuss AI's water footprint to better understand its environmental impact and ensure that the technological progress remains sustainable. That's from me.
All right, I see. Thank you for your insight on that matter, Savira. So you've highlighted an important point that although AI is often seen as a digital system, in reality it is actually a physical infrastructure that has real environmental demands, especially in terms of its water usage. So next, I would like to invite our second panelist, Soraya, to further elaborate on whether the public currently has enough information to understand the environmental footprints of AI systems. Go ahead.
Good evening, everyone. So before I answer the question, I would like to introduce myself. My name is Soraya, and I am the panelist two for today's discussion. To answer the question, honestly, the answer is no, and that is precisely the problem. And according to the RISE-GO 2026, the public only has access to rough and indirect estimates rather than actual figures, while AI system electricity demand could reach about 23 gigawatts by the end of 2025, and it's nearly half of the total global data center electricity consumption. No major company, including Google, Microsoft, Meta, or Amazon, publicly disclose any AI-specific carbon emissions or water usage data. In fact, out of 11 companies examined in the study, not a single one provides this level of detail. So as a result, the figures we have such as estimate 32 to 79 million tons of carbon dioxide emissions and 312 to 764 billion liter of water used by AI in 2025 are only rough estimates. They come overall companies' sustainability reports, not data that specifically measures AIs. And what's more concerning is that Google has said it will not report indirect water usage, even though this is closely linked to its electricity consumption. And so, to directly answer the question, the public is essentially being asked to trust environmental impact is being managed responsibly without being given the actual data needed to evaluate those claims independently. That is not transparency, and that is exactly the silent cost highlight in our panel discussion titles. I think that's all from me.
All right, thank you so much, Sorayya. You made a very strong point about accountability. So, building on your point, transparency is not only about what is visible to the public, but also what is being told by companies in terms of real environmental data. So, this now brings us to the question for panelist 3, Nurdini, who will talk about how AI infrastructure can potentially change the climate.
Thank you, moderator, for the first up. So, my name is Ramli, and I am the third panelist. So, to understand deeper on how artificial intelligence impacts the climate, my stance is that we have to look past the speculative idea of a digital cloud and look at the real and healthy physical buildings on the ground. An independent study by Muhammad Abu Bakar Siddiq, Ahmad Shahabi, and Landon Marston in 2021 used a highly precise spatial hydrological model that shows these massive computer hubs are a direct material threat to our water security under Sustainable Development Goal 30, SDG 30. So for putting the scale of this problem into a perspective, the research reveals that data centers in the United States alone consume a massive 130 billion liters of fresh water every single year. The real climate crisis here is a terrible geographic mismatch. So more than one fifth or over 20% of these data centers are built in areas where the local watersheds are already suffering from moderate to severe climate in this water stress. So this means that they are heavily disrupting local aquatic ecosystems and causing regional water tables to drop. And moving on, the researchers also uncovered that these data hubs put down about 1.8% of all the electricity consumed all around the world. This creates a double strain on our resources that is divided into a split 75% to 35% split. So 35% of the water is used directly at the facilities in evaporative cooling towers to keep the hardware from getting so hot that it melts. However, a massive 75% of the water is consumed indirectly upstream at the external thermoelectric power plants that keep the regional electric utility grids online. So in fact, half of the servers rely heavily on power grids that are located inside severely water stressed areas. So this gives us a perfect example case of how this infrastructure destroys local environments. And if you look at the data centers gathering in dry regions like the southwestern United States, that include Nevada, California, and Arizona, these facilities operate at a standard water consumption rate of 1.8 cubic meters per megawatt per hour. So since it is already so hot and dry around the area, the true water scarcity footprint in those zones ends up being more than double their normal water use. And this is causing a severe ecological friction. So this is the explanation for my part. Thank you.
Okay, that's really interesting. Thank you for highlighting the hidden environmental cost of AI infrastructure. So, from you, we got to understand that data centers not only consume a significant amount of water, but they also require a large amount of electricity to operate. So, on this point, it raises an important question on how does the increasing electricity demand of AI affect climate action efforts? So, for this question, I would like to invite our fourth panelist to discuss this question. Go ahead, Hanchang.
Thank you for that question. My answer draw from a 2025 article by Hackney, Koskun, and Savoko, published in iScience titled Why Transparency Matters for Sustainable Data Centers and Carbon Neutral Artificial Intelligence. Based on their findings, AI's electricity demand is growing fast enough to genuinely threaten our climate goals. They show that global data centers could consume up to 9% of total global electricity by 2030, with AI demand alone potentially reaching 800 TWh by 2026. comparable to the entire annual consumption of a mid-sized country. But the deeper problem is not just volume, it is timing. AI's computational demands are scaling far faster than clean energy capacity can match. So new AI-driven electricity demand gets absorbed by existing fossil fuel generation, not new renewables. We are not simply using more energy, we are reinforcing fossil fuel in infrastructure at exactly the moment SDJ 13 required us to move away from it. Hanchang et al. Also highlight that this is compounded by a transparency crisis. There is no standard disclosure of how much electricity AI actually consumes or where it comes from, making it nearly impossible to hold anyone accountable for AI's real carbon impact.
All right, thank you for the explanation on rapid AI growth and its increasing pressure on energy systems, which contributes to a greater fossil fuel dependence if not properly managed. So, moving on now that we've heard from all of our panelists, let's move to the second round of the discussion where we will explore how these issues are connected and what we can do in the future. So, for the first question, I would like to direct this to Sorayya. Given the environmental concerns surrounding AI, do you think technology companies should be required to disclose their water and energy consumption related to AI? You guys can decide who would like to answer first.
I would like to answer first regarding whether technology companies should be required to disclose their water and energy consumption related to AI operation. And to my answer is yes, and I believe it should be mandatory and not voluntary. So according to the Rise Go 2026, environmental disclosure among major tech companies is still limited and inconsistent. And out of 11 companies studied, only Meta provides relatively detailed information, while companies such as Amazon and ByteDance disclose a very little. In fact, Amazon does not even report its total electricity consumption, despite having the highest carbon emissions among the companies examined. So this shows that voluntary disclosure is simply not enough, and companies are choosing to reveal only the bare minimum, leaving the public with an incomplete picture of AI's environmental impact. Therefore, if we want genuine accountability and evidence-based policymaking, government should introduce binding regulation requiring companies to disclose AI-specific water and energy consumption rather than relying on company-wide figures. That's all from me.
Yes, I really agree to my fellow panelists that disclosure should be mandatory. So I would like to add that beyond accountability, transparency also helps the researcher and policymakers to measure that the real environmental costs of AI more accurately. So the without standardized reporting, it becomes very difficult to compare companies or track progress over time. So this lack of consistency can slow down efforts to design more effective the climate policies. So therefore, the mandatory and standardized disclosure is not only about the transparency, but also about enabling a better climate action and more responsible to AI development.
All right, I see. Thank you for the opinion from you both. So you both highlighted that transparency in AI related to reporting should not be voluntary on their behalf, but actually mandatory so that it can ensure accountability from the involved people side, and also that it can help provide more accurate environmental assessment to scientists and those related. So moving on, I would like to ask this question to Nurdini and Hanchang. As AI technologies continue to expand, are current environmental management strategies sufficient to address increasing heat generation and energy demand? I would like to invite Nurdini to share your thoughts first, followed by Hanchang, if that's all right. Go ahead.
It's alright. Okay, so thank you, moderator, for the question. To answer clearly, no. Our current environment strategies are completely insufficient because they ignore how interconnected our energy and water systems truly are. So while tech companies focus on local energy efficiency, in the independent research by Siti and his co-authors reveals a massive blind spot, and that is 75% of a data center's total water footprint. And this actually happens indirectly and upstream at the power plants supplying the grid. So as AI advances way faster than our clean energy capacity, it forces grids to rely heavily on fossil fuels, which in turn drains 130 billion liters of fresh water every single year. And since monetary guidelines do nothing to solve this, I would like to ask panelists for Hanchang from an energy perspective. How can any corporate strategy claim to be sustainable when AI's electricity demands force us to rely on these water draining fossil fuels?
For your thoughtful question, well, corporate voluntary rules alone cannot fix the issue. Today's environmental policies still have value. Many data center companies only manage their own cooling systems and overlook cold water waste from upstream thermal power plants. Yet new rules now require full life cycle water footprint assessments and ban data centers in water-scarce areas. Expanding solar and wind power alongside water-saving cooling tech also helps cut hidden freshwater consumption. The main flaw is that these measures are not legally required without strict government caps on AI's carbon and water usage. Businesses will keep choosing low-cost thermal power. Overall, current strategies are incomplete rather than useless. We need binding regulations together with a shift to renewables to build truly sustainable AI.
I completely agree with your point, Hanchang. So you totally hit the nail because as long as lifestyle type and renewable energy shift remain optional, platforms will always default to a cheap and resource-heavy thermal power. And this is exactly why mandatory regulations are the critical necessities. We cannot protect our vulnerable watersheds with a complete and voluntary corporate plans, while the climate faces immediate change. So I think true sustainability requires a free and non-negotiable legal laws.
I understand you will, but strict mandatory rules cannot apply everywhere. Many regions lack green power facilities and still rely on thermal power. Setting harsh limits will raise AI firms' costs and hinder tech progress. We should adopt gradual mandatory standards plus subsidies for renewable energy and low water cooling tech. In this way, we balance AI growth, water saving and climate protection, renewable energy, and low water cooling tech. In this way, we balance AI growth, water saving, and climate protection.
All right, thank you, Nurdini and Hanchang. So that was such a fruitful and informative discussion between you two. From what I got to catch, you guys both highlighted how the environmental impact of AI is not limited to a single issue, but instead it involves interconnected challenges related to water consumption, energy demand, and sustainable development. So, with the new information we've got, let's move on to the conclusion of today's panel talk. All right, so today's panel talk consists of the discussion of several environmental concerns related to the rapid growth of AI, including the importance of business transparency, the impact of AI cooling system on water resources, the heat generated by data centers, and the increasing electricity demand required to support AI technologies. Although AI has given us more and more benefits each day, today's discussion have shown that these advancements does not come without a cost. As AI becomes more involved in our daily lives, we must give more focus on the sustainability, resource, and climate responsibility. In the end, the question is not if we should stop AI from growing, but instead how are we able to responsibly control it to support both technology advancement while maintaining the goals of SDG 13, climate actions. So with that, this panel discussion has come to an end. I would like to once again express my greatest thanks to all the panelists for participating and also to the audience for maintaining your full focus. Thank you.